Hey, what's up, guys? Okay, so today let's introduce a very simple number, which is also also important in the number theory, so called a pentagonal number. Okay, so this is a really elementary. So okay, so simply speaking, you have an irregular polygon, and then you put a dot on this polygon, and you grow with one directions. Okay, so for example, the triangular number is okay. So this is n equals to 1, n equals to 2, n equals to 3, n equals to 4, n equals to 5, and then we use s as the s regular polygon. Okay, so this is the number. So 1, 3, 6, 10, 15, which is the triangular number. And the square number is trivial, which is 1, 4, 9, 16, 25. Okay, so obviously that for the n triangular number is n times n minus 1 divided by 2. This is just n squared. Okay. This pentagon number is a little bit tricky. So you get 1, 5, 12, 22, 35. So this is 1, 1 plus 4, 1 plus 4 plus 7, 1 plus 4 plus 7 plus 10. You can see that this is arithmetic progressions. This is 1 plus 4 plus 10 plus 7 plus 10 plus 13. Okay, so it's easy to compute these. Results, right? Compute this n pentagon number. You just need to do a simple calculation. Okay, hexagonal number is 1, right? 1 plus 5. Okay, and this is 1 plus 5, I think plus 9, and this is 1 plus 5 plus sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and also you can this is what? This is 13. Okay. Okay, and yeah, very simple. Okay, so our goal in this video is just very simple. Just find this PSN. So PSS is the S polygon, and the N is just the number. Okay. So in the Wikipedia, there's a amazing proof that one can check that one can just cut. For example, you can cut pentagon into a small polygon, a small triangular number. So amazing is that S count number can be decomposed into S minus 1 triangular number as a natural number. So there is a 5, right? You cut it. Okay, so from this point of view, your PSN will be S minus 1 triangular number. So it's n minus 1 divided by 2 plus n, because you got this black dot and the yellow dot. Okay, so this is your results. Okay, so proof done. Okay, so for example, you can put s equals to 5, that you get the polygon number. 3n minus 1 divided by 2 plus n. This is a polygon number. Polygon number is important because in the future that I will talk about the Euler pentagon theorem, which will use this pentagon number. Okay, when you put s equal to 6, you get a hexagon number. Okay, so this proof is quite tricky, right? So I mean, it's very hard to see why this is true. Okay, so let me just provide some elementary computation, which is also trivial, but it's interesting. Okay, so let's go back to this. So from this elementary calculation, that we can get something. We can just see this diagram and get the results, right? So let's say the first one always 1, right? And that's the second side. It will be 2, 2, 2, right? So I can just simply say that the second one will be 2 times 3, but in this case that there is an overlap. So I get 2, 2, 2, right? But there is a 2 overlap, so I should minus 2. So I get 4. So the second layer will be 4, and then for third layer I get 3, 3, 3, right? So I get 3 times 3, but there is a 2 overlap, so I should minus 2. I get 7. For the fourth layer, I get 4 times 3 minus 3, so it's 10. Okay. So from this, that I get this very simple rule. I know that PSN minus PSN n minus 1 will be the nth layer, right? So it will be n times s minus 2. For example, for s equals to 6, you get 4 sides, okay? Minus the overlap will be s minus 3. So you can change this into, let's say, n s minus 2 minus, okay, so let me just write this. Okay, so I can write this as n s minus 2 minus s minus 2 plus 1, which is n minus 1 s minus 2 plus 1. Okay, so from this elementary calculation, we get the following: s minus 2 n minus 1 plus 1. Okay, so proof is done, right? Because you can just directly compute. Your PSN by just do the summation. Okay, so you can just do the summation. Let's say s minus 2, and go from, let's say, I minus 1 plus 1, and then you go from I from 1, and let's say you go from what? You go from n, right? Okay, so which is s minus 2, and you get the 1 plus 2 up to n plus n, which is s minus 2, and this is, sorry, go to minus 1, right? So it's n minus 1 divided by 2 plus n. Okay, so this is just what you got previously. Okay, so this is elementary computation. You just see this little bit, and then you get the answer. Okay, that's it. So this is a very simple proof, of this pentagon number. Oh, sorry, that the polygonal number. Okay, and okay, there's a theorem I think is interesting, so I want to say a little bit. Is that every hexagonal number is also a triangle. Is also a triangular number. Triangular number. Okay, so what's hexagonal number? Okay, so let's see. Right, so 6 n hexagonal number will be 4 triangular number. Let's write t n. Let's write say will be triangular number. So t n minus 1 divided by 2 plus n. Okay, so simple calculation will be 4n squared minus 4n plus 2n divided by 2, which is 4n squared minus 2n divided by 2, which is 2n minus 1 divided by 2. Okay, so in terms of this and this, so we proved it. Okay, so very elementary. Okay, and yeah, that's it. I think this is just very simple series. Okay, so see you guys next videos.